Hello class, we've got one more section to finish off this chapter, and that is section 1.3, Physical and Chemical Properties. Our goal here will be to identify properties of and changes in matter as physical or chemical, and the other is to identify properties of matter as extensive or intensive. The characteristics that enable us to distinguish one substance from another are called properties. A physical property is a characteristic of matter that is not associated with a change in its chemical composition. For example, density, color, hardness, melting and boiling points, and electrical conductivity. A physical change is a change in the state or properties of matter without any accompanying change in its chemical composition. Butter undergoes a physical change when solid butter is heated and forms a liquid melted butter. Steam condensing inside a cooking pot is a physical change as water vapor is changed into liquid water. The change of one type of matter into another, that is, a chemical reaction, or the inability to undergo a chemical reaction, is a chemical property. For examples are flammability, toxicity, acidity, reactivity, and heat of combustion. In the case of flammability, it's propensity to react with the oxygen in the air. Toxicity is its ability to react with receptor sites of one sort or another in the body, and there are many. Acidity is its propensity to dissociate into the hydrogen ion and its counter ion. Reactivity is like exploding, like dynamite. And heat of combustion is the amount of heat released when it reacts with the oxygen in the air. One of the properties of iron is that it rusts, so it reacts with the oxygen in the air. One of the chemical properties of chromium is that it does not, under normal circumstances. It's used to make engines pretty. In this figure, we see that copper and nitric acid undergo a chemical change to form copper nitrate and the brown gaseous nitrogen dioxide. Now, don't confuse this with laughing gas, which is dinitrogen oxide. So this is NO2, and laughing gas is N2O. During the combustion of a match, cellulose in the match and oxygen from the air undergo a chemical change to form carbon dioxide and water. Cooking red meat causes a number of chemical changes, including the oxidation of iron in myoglobin that results in the familiar red to brown color change. There's also what they call the Maillard reaction, which is where carbohydrates react with proteins. That may be a more important thing than the oxidation of the iron in myoglobin. The banana turning brown is a chemical change as new, darker, and less tasty substances form. In industry, I've worked in industry for 20 years. This is a really big thing, the NFPA label. Actually, I think they've come out with another label, an international label. It's in a lot of ways the same thing. They've got these zones. This one has to do with health, fire, reactivity, and specific hazards. Bottom line is, 4s here are bad. 3s, not good. Most chemicals that you're going to deal with have 2 or less in these categories. And some may have no specific hazards, but Some are oxidizers, acids, alkali corrosives. Use no water or radioactive. We're not going to be testing you on the NFPA label, but in industry this is widely used, and you'll see it if you see barrels of chemicals. Chemicals have extensive properties and intensive properties. The extensive properties depend on the amount of matter present. So it's like the mass, the volume. By heat here, you could either talk about the sensible heat that it contains, that is, the heat simply due to the fact that it has a heat capacity and its temperature is elevated, or you could talk about heat of reaction and whatnot. But anything that increases as you increase the mass is an extensive property. Anything that is characteristic of the substance itself, regardless of how much of it you have, like its density, its temperature, you could even say its color, for example. These do not depend on the amount of matter present, and they are intensive properties. What people noticed as elements began to be discovered, and they noticed this they knew that one of the first things they knew about the elements was their atomic weight. Mendeleev in Russia started stacking the known elements according to their molecular weight, and he knew that certain ones had very similar properties, like lithium, sodium, and potassium. Especially sodium and potassium are very similar ions in that they have, well, very similar metals in that they're soft, they react with water very strongly, they form ions that have only one charge. Magnesium and calcium are very similar. They're very soft metals, and they produce ions that have a charge of positive 2, for example. And other things, nitrogen and phosphorus were known to form triply negative ions, oxygen and sulfur doubly negative ions. The halogens, as we now know them as, produce singly negatively charged ions. And what we also call the noble gases didn't react with anything at all. And as he added up the atomic weights, he noticed that they fell into certain categories, and he created this structure known as the periodic table. It was only later that scientists, through X-ray emissions, came up with this number, the atomic number, and realized that it corresponded to the number of protons within the nucleus, and constructed the periodic table based on the atomic number. But that's what we have today. And this periodic table shows how elements may be grouped according to certain properties. Now, these properties are the same going down. Note the background color denotes whether an element is a metal, metalloid, or nonmetal, whereas the element symbol, color, indicates whether it's solid, liquid, or a gas. So these are gases. This is a liquid. Mercury is a liquid at laboratory temperatures. Gallium is very, very close. I think you only have to get up about 80 degrees, so about 3 more degrees higher, and gallium becomes liquid, and it can be made liquid at room temperature as an alloy with other things. Sodium and potassium alloy into a liquid, but it's a highly reactive liquid. You want to have it touch water. Okay, that's a brief introduction to the periodic table. And that is all we need to talk about in this installment. Thank you very much indeed.